Good evening, all. So let's start today's class. So in today's class, first we're going to see about one divide and conquer algorithm. Okay, that we missed out in last class, and then we'll go to greedy strategy. Okay, so it is actually a simple algorithm. So the algorithm is finding the median of two sorted arrays of same size. Okay, that is the problem. Finding the median of two sorted arrays of same size. Okay, so you'll be given with two arrays. Array means here list. Okay, so you have to find out the median of the two sorted arrays combined together. It's a combined median. Okay, so suppose if so, what is the median?
Midpoint.
Midpoint. Okay, so midpoint in a sorted array actually.
Yes.
Okay,
Yes,
so if it is if it is an unsorted array, the first is you have to sort it, and then you have to find the midpoint. So if there are odd number of like elements, then it is easy to find out the midpoint. Okay, so there'll be only one midpoint, so that would be your median. So if you have uh, even number of elements, okay, then you don't have the exact midpoint, right? You have two elements which will be in their mid position. So in that case, you have to find the average of those two.
average.
Average of those two elements, and that would be the median of the entire array. So that is the median. So now what you're going to do is you're going to find out the median of the combined median of two sorted arrays. So let us take, for example, two sorted arrays of same size. Array A. So array means in the here I mean to say it is list. Okay. 12, 15, 26, 38. Mm. So what is the normal procedure to solve this problem? So I want to find the common, that is the overall median of these two arrays. So what do you think would be the normal procedure? So you should find
So
the
we can combine the list.
correct. So you should combine it. So like you have two sorted arrays. So what procedure shall we use to combine? In merge sort already we saw one algorithm, right? Merging two sorted arrays. Okay, the same process can be applied here also. And using that process, you can solve this problem. Okay, you can merge them. You'll get a single sorted array. And in that single sorted array, you can find the middle element and then find the median. Okay, so what would be the complexity of that algorithm if there are n elements in each array, each list? What would be the complexity? What is the complexity to merge two arrays to list?
N.
There are n elements in each array.
So 2n.
Yeah, correct. So it is n plus n, which is nothing but 2n.
2n.
So that is the complexity, order of 2n. Now let us try to find out a simpler algorithm, and then let us see whether this 2n can be reduced. Okay. So in divide and conquer, what we would be doing is, I'll give the illustration, then we will come to the implementation. I think implementation should be easy. So you have array A and array B. Okay. So you're going to find the median for array A and median for array B individually. Okay. So what is M1? M1 is nothing but the median of array A.
15.
Yes. 15. And median of array B is
17.
17. So here you can see that M1 is less than M2, right? So if M1 is less than M2, it is obvious that median should be either present in the right hand side of A or should be present in the left hand side of B, right? It would not be present in the left hand side of A and in the right hand side of B. Are you able to understand this? Why? Because M1 is less than 17, M2, right? So we can concentrate only on these set of items from 15 to the last and then from the first of B to 17. Because if so we have found a threshold, right? Beyond less than this, it is not possible. Likewise, greater than this, it is not possible. Everybody get it?
Yes, sir.
Okay. Now what happens? Next, A becomes only the right hand side values and B becomes left hand side values. So proceed this algorithm till you get a two element array in both the list. Okay. So now what is M1?
26 and 13.
26. And M2 is 13. Okay. So here M1 is greater than M2. It means what? It should be in the left hand side of A and in the right hand side of B if all median is present. Okay. So we can skip these elements 38 and 2.
Mhm.
So A becomes 15 and 26. B becomes 13 and 17. Okay. So now we have come to the end. Okay. So that is we reached the position where both the arrays are having only two elements. Okay. So once you reach this, you can find the median by using this formula. Max of the first elements, okay, that is A of 0 plus min of the second elements divided by 2. So you're finding the maximum of the first element and the minimum of the second element. So and take an average of that, you will get the answer. Okay, so this is the procedure. Now there is one way to stop in the middle. Okay, so the thing is, if you get both M1 and M2 equal, okay, in somewhere in the middle, suppose if M1 and M2 both are equal, so now what would be the answer is that value, whatever you're getting, that would be the answer. You need not proceed further because at the end also it is going to end up in that element only. Understood? Okay. So if we apply this formula, what is the median? Max of the first element. So which is 15. Min of the second element, 17. Divide by 2, you'll get 16. 16 is the answer. Okay. So now let us see the combined array, which is nothing but 1, 2, 12, 13, 15, 17, 26, 30, 38, 45. Okay, so here also the middle two elements are 15 and 17, and the median is the average of these two, which is 16. Okay, so what is the complexity of this algorithm? So here it is exactly following the way in which binary search was working, right? So it found the middle, it skipped the left off, takes only the right off. So like that, every time it takes only half of the elements. So obviously it is log n. Okay, from n it got reduced to log n. So understood this, right? So procedure is also simple. So what you can do is you can just find the middle. So if you can just do a comparison between m1 and m2, and whenever you find that m1 is greater, okay, great m1, sorry, here m1 is less than m2 means take the right half of a and the left half of b. And if it's the other way, if m1 is greater and m2 is lesser, take the left half of a and right half of b, and proceed this till you get a two element array. So once you reach two element, then apply this formula, you'll get the answer. Okay, understood this? Any doubts?
Yes.
Okay, now let us go to today's topic, greedy strategy. So greedy strategy is a very simple strategy. So as the name suggests, we're going to be greedy while solving a problem. Okay, so we're not going to worry about the future, whether it is going to lead to a solution or not. So whichever is the optimal solution, which we feel that is optimal as of now, that would be considered as the solution, and then we'll keep on proceeding to find the next levels. Okay, so like we see examples, then you'll get a clear picture. Now, a greedy strategy contains only two steps. Okay, so one is forming a greedy sequence. You'll be given with a set of data. Using that set of data, you need to do a sequencing, okay, in a greedy manner. First is forming a greedy sequence. Second is using this greedy sequence, you have to form the solution. Okay, sorry. Using the greedy sequence. That's all. Okay, so we can take examples and try to understand clearly what exactly is greedy strategy. So the best example to illustrate greedy strategy is the coin change algorithm. So the algorithm says that you'll be given with a total. Okay, so like okay, so first you'll be given with a currency. Okay, let us take the Indian currency, and you'll be given with all the denominations of the Indian currency. Okay, and you have n number of coins in each denomination, and the problem is you have to reach the target with the minimum number of coins. I'll repeat again. You'll be given with with the denominations of a particular currency. Okay, here we let us take the Indian currency. So you'll be given with all the denominations, and there are infinite number of coins in each currency, and you have to reach a target sum with the minimum number of currencies, minimum number of coins. Okay, so that is the problem. For example, so let us take the target sum as 5,678. Okay, this target sum should be reached. Okay, so let us go to the Excel sheet and then understand. So the target sum is 5,678, And the various denominations in Indian currencies. So I'll write it here, and then we'll just do a sequence there. So the various denominations are, we have 100 rupees, 200 rupees, 2000, 500, 50, 20, 10, 2, 5, 1. Okay, so these are the various currencies available, denominations available in the Indian currency. Fine. So now, which denomination would you take to first fill this total?
2000.
Yeah. So if you take 2000 only, like, so it is the largest number, right? Okay. So with minimum number of coins, we'll be able to fill the maximum sum if you take the maximum value. Okay, that is the basic idea. So here, what kind of sequencing we have to do with this given denominations? We have to order it in descending order. Okay, based on the
Descending order.
denomination values. Okay, so if we arrange it in descending order with respect to the denominations, you will get first 2000, 500, 200, 100, 50, 20, 10, 5, 2, 1. Okay, so now, so these are the denominations. Now next, let us find out how many denominations, okay, how many coins in this particular denominations we are taking. Just count. Okay, and if we take these many amount of coins, what would be the total? Suppose you are taking 2000 rupees, you will get some total, right? That total we are going to write it here, and this would be the balance amount. The last column, let it be the balance. So what is the current balance? That will be updated in this column. Okay, so as of now, initially it is 5678 is the balance. Now let us see. So how many 2000 rupees coin can be filled in this 5678? Maximum number of 2000 rupees coins?
2.
2. So what would be the total?
4000.
4000. And the balance?
1678.
Yeah, 1678. Now the second largest denomination is 500. So how many 500 rupees coins can be used to
3.
fill this balance? Yeah, 3. And total is
1500.
500. And the balance is
168. 178.
178. Yeah. Next 200 rupees, I'll not be able to take any 200 rupees. So count is 0.
0.
0. Balance 178. 100.
1.
1. 100. 78. 50. 1.
1.
50. 28. 20. 1. 28. 10. 0. 0. 8. 1. 5. 3. 1. 2. 1. 1. 1. 0. Okay, finally you'll get 0. So now we can see that. So we didn't even think about the future, right? So whether this will lead to a solution or not, we never thought about that. As of now, 2000 was, how much ever 2000 rupees I was able to take, I was taking it. Okay, I didn't think about whether this 2000 rupees taking 2000 rupees will lead to a solution or not. I never thought about it, right? So this is actually greedy strategy. Okay, and the first step was sequencing. So it was given in some random order. The current denominations were given in some random order. So what we did is we sorted it in descending order, which is the greedy sequence which we did. And using this greedy sequence, we formed the solution. Okay. So if we don't apply this greedy strategy, what would have been the other possibility to find the solution? So it is actually a combinatorial problem, combination problem. Okay, you have to find out all the combinations, whichever will lead to a solution, total target. Okay, and among all the solutions, you have to find out which is a minimum, right? So just add all these values, you'll get the count of the total coins that we are using. So you can see that this would be the most optimal solution. You might get a solution which is equal to this, but not better than this. Okay, fine. So now, okay, if you are using a brute force method, it would have been a factorial problem, right? So always combination itself means it is a factorial problem. So you can see what is the complexity of this algorithm, greedy strategy algorithm. What all operations are we doing?
Multiplication and
Yeah, first we are
subtraction.
sorting. First we are sorting.
Sorting.
Yeah, after that, yeah, we are doing a division here first. To find the count, we are doing a division. Okay, and then like, so how will you get the balance?
Subtraction.
Okay, actually this total is just for our reference you wrote. Do you need to subtract, or is there any other operation to find the balance? You can just take a modulo, right? Okay, so
Yeah.
5678 modulo 200 will give you 1678. And this 2 is by division. Okay, division operation and then modulo operation will give you these both values, and we can like do it iteratively for all the denominations. Fine. So that will take an n time, and then for sorting, the best sorting algorithm itself n log n. So for sorting it is n log n, and for forming the solution it is n. So the overall complexity would be n log n plus n. Okay,
Yes.
fine. So this is the first problem. Now let us see one more problem. So we'll just see all the problems in present in eBox. So second problem that we're going to see is knapsack problem. Just a minute. Knapsack problem. So what is knapsack problem? Any idea, anyone? So how many are there? Okay. So knapsack problem is nothing but you'd be having a sack. Okay. In that sack, and that sack is having a capacity. Capacity would be given the same unit as the weight. Okay. So if it is kg, weight is also in capacity is also in kgs only. So beyond this, we cannot carry the item. So it is the capacity of the sack. So irrespective of the volume. Okay. So only the weight has been given as a constraint here. So volume is not considered. Okay. So here, like capacity of the sack is 7. Now, and you are given the list of items. So now what you're going to do is we're going to like dump these items inside the sack with which will give the maximum profit. Okay. So that is actually the problem. So can you tell me the applications where this knapsack problem can be used? Think in real time. You can give a lot of examples.
So can you explain knapsack once again?
Okay. So knapsack problem is nothing but you'll be given in the sack. Sack is nothing but a bag. Okay. So and that bag is having a capacity. Suppose the capacity of the bag is 7 kgs. And you have been given the list of items. And along with the item list, we have the weight of each item and the profit. How much profit you get, the valuability of the item. So you're going to dump this bag with these items So you cannot dump all the items, right? Because it has a capacity. The total weight is more than the capacity. You cannot take all the items. So you have to choose between the items. So which is the best combination so that you'll get the maximum profit? That is the knapsack problem. Any examples? Suppose you're a robber and you're going to a house to like rob the things. So now you have a bag, right? And you have a lot of things. So you have so your house means it will be filled with a lot of items, right? So there may be very big items, very heavy items. Okay, like vessels would be there, TV, washing machine, fridge, and jewels also would be there. Costly dresses would be there. Okay, and then um, photo frames would be there. Okay, like that you have lot of items are there. So among those items, he would give a profit for each item. So jewels means it has a very high profit. Okay, so likewise TV also has good profit, but weight is more
Heavy.
heavy. Yeah, likewise vessels, they are heavy, weight is also less. Sorry, heavy
Profit is
but
less.
profit is also less. Okay, if we take photo frame photos and all, weight is less, profit is also less.
Mm.
Okay, like that you have various combinations. So now we have to make a priority list. Which one if we takes it gives a more profit, like that. Okay, like that. This is one example. And if you go to if you take if you're going for trekking, okay, so there you'll have a bag. So you will have some capacity, right? You cannot carry more than this weight, like that. So like if you carry more also, you'll become more tired easily. So you'll choose the priority. So how much snacks you need to carry, so how many like uh, uh, tools you need to carry.
Mm.
Okay,
Clothes.
yeah, rope, clothes, snacks, so like that you'll give priority. So you'll take lighter weight clothes, and so high energy snacks, and then knife, torchlight, rope. So like that you will prioritize, and then you take the items, right? Likewise people going for military camp, there also knapsack problem can be applied. So there are a lot of examples of that. So there are two types of knapsack problem. So one is fractional knapsack problem, and other is 0 or 1. Okay, so fraction means you are able to take a fraction of an item. Okay, suppose you go to a grocery shop. So if you want to take rice or sugar and loose, that is possible, right? Okay, it is not that you should take only 1 kg. You can also take half kg, 250 grams, 100 grams, like that. Okay, so just to fill the sack. So you have a sack, and then some empty space is there. Okay, so in that empty space, you can take a fraction of some of the items and then put it inside it. Okay, so that is called fractional knapsack problem. So zero around knapsack problem means either you have to take it or leave it. Okay, so if you go to a toy shop, okay, so either you have to take the toy or you have to leave the toy. You cannot take a part of the
Ah.
toy and then go, right? So there are two types. So this fraction knapsack problem can be solved using greedy strategy, whereas zero or one knapsack problem, we should approach it some other strategy, because we cannot apply fraction greedy strategy. Okay. So before that, I'll tell you when all we can apply greedy strategy and when all we cannot apply greedy strategy. So in the previous problem, okay. So in this coin change problem, suppose if this one was not there, okay, if this one was not there, so is it possible to apply greedy strategy?
No, sir.
One in the sense like this one itself has been removed.
Denomination. No.
Denomination is removed.
No.
So yeah, we cannot apply greedy strategy because what happens at last you are ending up with one which is not
Balance.
filled. But there are other solutions. Okay, I can make this as 0, and then I can make this as 4, and then I'll get the solution. Okay, but this is not greedy strategy, right? As per greedy strategy, if I'm able to fill with a particular coin, I should fill it. Then only I should go to the next denomination. Okay. So like only if there is the minimum possible, the least possible, which using which you can fill any balance which is given. There is any target which is given. Then only you can apply greedy strategy. I'll repeat again. So with this 1 rupee coin, whatever might be the target given, I'll be able to achieve it, right? Okay. So if there is any left out, I will be able to fill with this one. Okay. If that is the case, then I can apply greedy strategy. So even if it is an even number or odd number, whatever values given as total, I'll be able to fill with this one. Whereas with two, I'll not be able to do. Whereas only with five, I'll not be able to do. Okay. Got it. So since one was there, I was able to apply greedy strategy. So likewise, here also, if there is any free space, I can take a fraction of any of the items and then I can fill that. Okay, that is why fraction knapsack problem can be applied, solved using greedy strategy. Okay, now let us see the solution. Okay, in the previous problem, we had only one sequence. So we directly applied any of the sorting algorithms and then got the answer. Now here we have two sequences. Two parameters are there, actually, weight and profit. Now, how should I do the sequencing? Both are important, right? Okay. So I should consider weight as well as the profit. I cannot leave one and use another. Okay. So in this case, what you have to do is you have to try to group these two parameters, or how many other parameters it may be. You have to group the parameters and then form a single sequence. Okay. So now what you're going to do is you're going to check like how these two are behaving. So here weight. So what we will do is we'll try to reduce the weight, right? And then we'll try to increase the profit. Both are contradicting, right? Both are inverse in nature. So in that case, what you would do is you would find the ratio. Ratio means just you will divide these both. Any doubts? Okay. So now if both are same in nature, if both needs to be increased, in that case, you should not find the ratio. You should find the product. Okay. So suppose you have one more parameter. Let's say you have cost. So weight is there, cost also one more parameter is there. So what would you try to do? You will try to reduce the cost, right? You'll try to reduce the weight. You'll try to reduce the cost. You'll try to increase the profit, right? So you have three parameters. So in this case, what you would do is you will multiply weight and cost because both are same in nature. Okay, and profit is different from these two. So like that, you will do a grouping. So which all parameters has to be increased. Okay, that is yeah, it needs to be, these two has to be decreased, right? So weight and cost has to be decreased. So all the parameters has to be decreased to be put in a group, and all the parameters that has to be increased to be put in another group. Find the product within those group. Okay, group one has to be multiplied, group two has to be multiplied, and then divide group one and group two. Okay. So if you are dividing group one and group two, you should find which one is at the numerator and which one is at the denominator. So here let us find profit by weight ratio. Profit by weight ratio means the value which has to be maximized is at the numerator and the value which has to be minimized is at the denominator. If that is the case, you have to sort the final sequence in descending order. Okay, so I'll tell you how to find all those things now. So now let us find out the profit by weight ratio. So what is P by W for the first item? 2. For second item?
3,
3.
5,
Third item? 5.
4.
4. Okay, so to find out in which order we need to sequence is very simple. Just take the two extremes. Okay, so item 3 is having profit to weight ratio 5 and item 1 is having profit to weight ratio 2. Okay, so just compare. So here item 3 is only 3 kgs and it's giving 15 profit. Okay, and item 1 is 4 kgs and giving only 8 profit. So among item 1 and item 3, which one would you choose?
3.
3, right? And this would be the last option. So now what you have to do? You have to sort it in descending order. Okay, that's it. So if you are finding out weight by profit, then you have to sort it in ascending order. That's all. Okay. Now, so when will you go for ascending P by W or W by P is while doing manual calculations and all. Like if you are doing automated calculation using computer and all, you can find any of these methods, either P by W or W by P. It is okay. But if you're doing it manually, you'll find it easy if you have whole numbers or integers, right? Okay. So if you find weight by profit, then what happens? Profit is larger numbers, right? So you'll get all decimal values. Okay. So it is easy to like infer from integers than from decimal. So you find out which element is larger. You put it as a numerator. That's it. Okay. So if you're writing a program, then fine. Either profit by weight ratio or weight by profit ratio. System is going to take the same time. But human beings, right? We have to uh, choose. Okay. Fine. Now we have found out the profit by weight ratio. Now let us do the greedy sequencing. So the first item that would be taken is third item. Second item is profit by weight ratio 4. We'll take fourth item. And then second item, first item. Okay. Now I have done a sequencing. Now I would find out how much fraction of that item I'm taking. So if my sack is free, okay, if, space is enough, that is, it can hold the entire item, means I'll take the entire fraction. Else I have to split this item and then put it. A part of that item has to be put, right? A fraction of that item has to be put. And what fraction I'm taking, that is to be filled over here. And so I'll write FP. FP is nothing but fraction profit. Okay, if I take only half of item, so then the profit also becomes half, right? Okay. And then the balance weight. Initially balance weight is 7. So now will I be able to take the entire item? 3. And one more important thing, the frequency, that is the count of each item is only 1. I cannot take multiple items at a time. Okay, only one item is there. If I have multiple items, then you'll have one more column representing the number of items present. But here, only one item of each category. Okay. So now the balance weight is 7 and the weight of item 3 is only 3. So I'll be able to fit the entire item. So the fraction is 1. So the fraction will be from 0 to 1. Okay. So 1 means entire item, 0 means not taking at all. So FP, so taking the entire item, so the fraction profit is 15 itself because we're taking the entire item. So fraction profit is nothing but whatever fraction you're taking multiplied by the profit. Okay, very simple. And what is the balance?
4.
4. Now will I be able to fit item 4 inside the sack?
Yes.
Yes. So entire fraction profit
4.
Balance
0.
no, only one, right? Wait, 3. Weight is 3. Profit is only 4. Okay. Now, second item, will I be able to fill in the sack?
Yes, sir.
Yes, because weight is only 2. I have balance 3. So entire fraction. Okay. Now the profit 6 and then balance is
1.
1. Now, item 1, weight is 4. Now, will I be able to fill this entire item inside the sack?
No.
No. So what fraction should I take?
1 by 4.
1 by 4. So this is also very simple. Just divide the balance with the weight. That will give the fraction. Okay. So it is 1 by 4. So the fraction profit also becomes 1/4 of the profit. So what is the fraction profit? 2. Yeah. And the balance is 0. And add all this profit. What is the total profit?
27.
27. So this is the maximum profit achievable. Okay. You will not get any. So you might get, if you apply a different combination, you might get a same profit, but not better than this. Okay. This is the optimal solution. Again, if you see, this is a combination problem, right? So if you do it brute force using brute force method, you have to find out all the combinations and find out which is the maximum profit you are obtaining. So again, it is an n factorial problem. So what is the complexity of this algorithm using greedy strategy? Again, here we are doing a sequence and then
Division.
we are,
Division operation.
yeah. So all these are n only, right? So first we are finding out profit by weight. For that one n.
N log n plus n.
N log n plus some fraction, some coefficient into n. Okay, that coefficient is nothing but we are finding the profit by weight ratio. Here one n would be there, and then finding the fraction balance. Okay, fraction profit. Okay.
Okay.
So some constant into n. Okay, n log n plus cn. Okay, c is some constant. Okay. So this is fraction Knapsack problem. Oh, let us see a few more problems. Okay, so we'll discuss all these problems. The first problem is a coin calculator, which the first problem that we discussed, no? The same problem. This is coin calculator. Second problem. Okay, so I'll just tell the problem. Let us read the problem. So a girl wants to store n number of songs in a tape. Initially, the tape is empty. So tape means like in the olden days we have the tape recorder, right? So nowadays we are able to like simply click the button and then switch the songs. But in olden days it was not that case, right? You have to start from the first, and then you have to go to the next song. We don't know where the song comes. All those things are there. So that is the scenario here. Okay. So a girl wants to store n number of songs in a tape. Initial Initially the tape is empty. She wants to store the songs in some order so that the time needed to retrieve each song will be minimal. Okay, retrieving a song means like you're going to the end of a particular song. So please help the girl to store the songs in the tape by ordering it in such a fashion. In such a fashion means like to meet this objective. Okay, so to retrieve the songs in a minimal number of time and also find the optimal mean retrieval time. Okay. So let us assume that the pointer always get reset to start position. Okay, once you retrieve a song, okay, automatically it goes to the start position. Fine. So now there are 3 songs. So the problem is you'll be given the song along with the duration, length of the song. So first song is 5 minutes, second song is 10 minutes, third song is 3 minutes. So like if we arrange it in the same order, let's suppose we are arranging the songs in the same order. So now what happens? So the first song, 3 minutes. The second song will be the next position, which will take, sorry, first song is 5 minutes. Second song will be the next position, which will take 10 minutes. The third song will take, total length is 3 minutes. Okay, first song is there, second song, third song, consecutively it is present. So to retrieve the first song, we need 5 minutes, right? To come to the end of the first song, we need 5 minutes. Now what happens? automatically it will get reset to the start. Now again, to retrieve the second song,
15 minutes.
yeah, it'll take 15 minutes to reach the end of the second song. Right? Now it gets reset to the starting position. To retrieve the third song,
18 minutes.
18 minutes. Correct. Okay. So the first song to retrieve will take 5 minutes. Second song will take 15 minutes. The third song will take 18 minutes. So what's the total retrieval time?
38.
38, right? Okay. So it takes total of 38 minutes to retrieve all these three songs. Now we have to do some ordering in such a way that this 38 can be reduced. Okay. So now, so what would be the solution? Any idea?
So ascending order.
Yeah, very good. So we have to sort it in ascending order, right? So if the smaller songs are in the first, so what happens to reach the second song? We can reach it very quickly, right? If the smaller, shorter songs are in the first. Okay, so now let us do in that order. So first 3, and then 5, and then 10. So to retrieve this first song, okay, so actually it is song 3, right? So yes, 3
3
will take
minutes.
3
3
minutes.
minutes.
So song 1. So this is song 1, right? So I'll write here.
5.
So for retrieving song 1, it'll
5.
take
5
8.
minutes.
8.
Okay. Retrieve.
8 minutes. And song 3,
Plus
18.
10. 18.
Okay, what's the total retrieval time?
3.
11 plus 18.
29.
29.
29.
Yeah. So initially in this order it was 38 minutes. Now you can see that it is taking only 29 minutes. And again, this is the optimal solution. Okay. So again, if you see this is a brute force method, if you take brute force method, it is a combination problem. So here, just by doing a sorting, we are able to achieve this. Okay. So this is the second problem. Understood, right? Any doubts? Anyone? Okay. So the second problem is, the third problem is activity selection. So these are all different types of problems. Okay. So the problems might not be the same. See, instead of song, it can be anything, any other things also. Like you have a huge pipe filled with the different colors of water. Okay. So and suppose in place of song, you can have a movie. Okay. Like that you can just imagine. So this is just a you can use it as a template. Similar kind of problems you have to do. Okay, all the problems will not be the same, right? So like this is a second variety. Okay, so activity selection. So let us see the problem and then we can uh, generalize this problem, what it would be. Okay, so you're being appointed as the program manager for the cricket ground. Since it is a weekend, a lot of cricket matches are going to be conducted in the ground. As the manager of the ground management team, you aim to your aim is to earn more profit by conducting the maximum number of matches in the ground. Okay, the objective is to conduct the maximum number of matches. Okay, assume that only one match can be conducted at a time. Write a program to schedule maximum number of matches. Okay, and you can see and assumption the maximum number of matches do not exceed 20. Okay, so they're telling that number of matches that are going to be played is not greater than 20. So that doesn't matter. See here, the input is you're given with the match name and the start time and the end time. Okay, so let us see the problem. The problem is you're having a ground, and you need to um, conduct as many matches as possible. Okay, and here it is irrespective of the duration. So even if the match is going to be played for 10 hours or it's going to be played for 1 hour, it doesn't matter. Okay, the objective is you want to play maximum number of matches. You're going to schedule maximum number of matches. That is the prime objective. So it doesn't bother, don't bother about the duration of the match. Okay, fine. So now let us write all these matches. So name doesn't matter. Okay, let us have it 1 2 3 itself, and we have the start time and the end time. So let us note down the start time and end time alone. So 1 2 3 4, here is 0 0 6 5 7 8 9 5 9. So match 1. Fine. Okay. So can you think about the solution? What greedy sequence you have to do?
So first we'll find the duration of each match,
Okay.
and then in ascending order.
Duration in ascending order.
Yes.
Okay. Fine. So now let us see that is giving the correct solution or not. So duration 1 1 6 2 1 4. Okay, so if you sort it in ascending order, you have match 1, match 2, match 5, match 4, match 6, and match 3. Okay, so let us mark yes or no whether the match is played or not. So if there is an overlap, we will not be able to play that match, right? So here 1 and 2, this is the first match which you're going to consider, right, in ascending order. So no other matches are being played. So what happens? We can allocate this match. So yes. And next in order comes match 2. From 3 to 4, ground is free. So I can allocate this match. And next which comes in order is match 5, 8 to 9. Again, the ground is free at 8 to 9. You can allocate this match. And the next which comes in order is M4, 5 to 7. 5 to 7 also, it is free.
So 5 to 7 will be a clash with M5.
With M5, why? M5 is 8 to 9 only, no?
Okay, sorry.
Okay, so M5 is 8 to 9. And you can see these also 1 to 2, 3 to 4. So 5 to 7, ground is free only. Okay. And then next which comes in order is 5 to 9. So this only will have a clash. Okay, so no. And M3,
0 to 6. This will also be it.
yeah, clash is there. So no. Okay, so as per this strategy, sorting with respect to ascending order, with respect to duration in ascending order, gives 4, right? Okay, so for this example, this might give the optimal solution. Okay, but duration is not the correct answer. So can you think about a test case where the duration is not going to give the correct answer? Think about a test case where duration is not the correct answer.
So when like there are clashes in the time, no? So those cases duration will not be helpful. Like Over here also we saw clashes.
Yeah. Okay, I'll
So
give an example. M1, M2, M3. So here, match 1, the start time is 6 and the end time is 9. Match 2, the start time is 1, end time is 7. And match 3, start time is 8 and the end time is 12. So what is the duration?
3,
3,
6,
6,
and 4.
4. Right? So if match 1 is played, okay, as per duration, this is the first match, right?
Mm.
So match 2 and match 3 both cannot be played.
6, 9. Yes.
Okay.
Mm.
So this both becomes no. But whereas if match 1 is not played, these two matches can be played.
Yes, there are no clashes there.
Yeah. So which means that we have one test case where duration is not working correctly. Okay. So now what might be the correct solution? Okay, I'll tell you. So you have to sort it with respect to the end time. Okay. So if you know the end time, it is easy to find out when the next match can be scheduled, right? Okay. So suppose if you are starting with respect to start time, so the first match it starts at 0, it might take the entire day also,
Mm.
right? If it's played for 24 hours, so it might take the entire day also, right? No other matches can be played. So the correct solution is you need to sort it with respect to the end time. So if you know when it is ending, immediately you can start the next match without the over, which is going to end at the minimum time. Okay, next end time. Okay. So now, if we sort it with respect to end time, see this in this example, it's already sorted with respect to end time only.
Mm.
So, like if we see, we can write this solution here. So, is it possible to like allocate match 1? Yes.
Yes.
No clashes. So yes. So match 2,
Yes.
also no clashes. Yes. Match 3, no, because starting at 0. Okay. Already there are two matches that played at 1 to 2 and 3 to 4. So this cannot be played. No. And 5 to 7, no clash. Yes. 8 to 9 also no clash. Yes. 5 to 9, there is clash. So no. So this is the optimal solution. Okay. If you take this case also, if we sort it with respect to start time, this is sorry, end time. This is the first match that should be allocated, right? Match 2. So first, so we can play match 1, sorry, match 2. And the next match which comes is match 2, which is ending at 9. This cannot be played because there is an overlap.
Mm.
No. So then the third match, it can be played, no overlap. Okay. Yes. So sorting with respect to n time is the correct solution. And so this problem can be generalized with so you have one resource and you have multiple requests. Okay. So you can map this to any other scenario, whatever scenario you want, you can map to. You have one a machine, one printer, okay, and then multiple jobs are coming with the various number of pages.
Mm.
Okay, so which like job we can allocate first, which all jobs you can schedule. Okay, so like that you can think of a lot of other scenarios. So that is this activity selection. Okay, you have one resource and multiple requests based on the time. Okay, fine. So the next scenario, knapsack problem, VD strategy. This we already saw. Next is a machine allocation. So in this problem, okay, let us read the problem. It will be quite confusing. Okay, now let us read, then I'll tell the general format. So, a man who is owning a garment factory, recently he has faced with loss in his factory. So, at that time, he is getting an order from a big clothing company. With the minimum number of machine resources, he have to complete the order without facing any loss again. Since the cloths are going to be really modern, the time taken for stitching the cloth would take different time. Okay, so like each work with different time. So like according to the each cloth stitching time, allocate the machine resources. The order of the job. Okay, so that is a solution actually. Fine. So this problem, you are having many number of like resources. Okay, so lot of machines are there, n number of machines are there. You want, if you can use any number of machines. Okay, the objective is you have to minimize the number of resources. Okay, like let us suppose, assume these machines as tailors. Okay, so you're giving the cloths to the tailors to stitch and give. Okay, so now if you are able to like allocate minimum number of tailors, if they are daily wages, okay, what we can do, we can reduce the cost of paying them, right?
Mm.
Okay, so now let us take this example. You have job and you have the start time and end time. Okay, 08 2536 920 17 11 17. You have job 1 2 3 4 5. Okay, so now what you have to do is, so I'll tell the solution. See, actually you have to sort this with respect to the start time. Okay, so you have any number of n number of machines, right? So whenever a new like job is coming, okay, whichever machine is free, just keep on allocating them. Okay, whichever tailor is free, allocate the tailor with the new job, new cloth. Okay, so that's it. So first we are taking machine one, and the criteria, the sequence in which you have to do is you have to sort it with respect to start time in ascending order. Okay, so the first is already given in ascending order, but it might not be in ascending order, you have to sort it. Okay, the same case for the previous problem also. So here the first job is the okay, job one is the first job that is coming in. So it starts at 0th minute and then ends at 8th minute. Okay, I'm just going to note down the end time alone. Job 1, it ends at 8. So that I'll know when is it ending and then I can allocate accordingly. Okay. So now the second job which comes is at second minute. Okay. If it comes at second minute, I cannot allocate this to the same machine, right? Machine 1 I cannot allocate. So I have to definitely take the second machine. M2 should be taken. And it is job 2 and the end time is 5. Now the third job is starting at 3. If we see at 3, machine 1, machine 2, both are not free. Okay. So I have to take machine 3. And job 3, it ends at 6. Okay. So now machine, sorry, not machine 4. Now next job which is coming in is at 9th minute. If you see at 9th minute, all the 3 machines are free.
Mhm.
Okay, if all the 3 machines are free, you don't like do any choosing and all. Whichever machine is first free, allocate to them. Okay, don't worry about this was free for 4 minutes, so I have to allocate for this. Not like that. So whichever machine comes first, which is free, allocate to that machine. So here job 4, which ends at 20. And next to job 5 comes at 11. You can see that machine 1 is not free. So machine 2 is free. So I can allocate job 5 to machine 2. So this is the optimal number of machines that can be used. With minimum of at least 3 machines, we should is needed, okay, to solve this problem. Understood? Any doubts?
Okay. So can we solve this by sorting an ending time also?
Okay, let us see. Actually, that would not lead to a solution, but it here, okay, it is not in a end time, right? Okay, let us see whether it is coming in correct order. Else we can find out a test case where it is not working correctly. Okay, fine. So if we sort it in ascending order, sort the end time with in ascending order. So the first job would be job 2, right? So this might give a solution, I think. So M1, job 2 ends at 5th minute. Okay, and the second job which comes is job 3, machine 2, and it is job 3, and the end time is 6, and it is M3. Okay, I think this would give us correct solution. Okay. Job 1,
8.
8, and then job 5, 17, job 4, 20. So here also 20.
Same
Sorry,
answer.
here also 3. Okay, can you tell me a test case where the end time will not work correctly?
So
Let's try this one. So if the start is in this 8, first this will be allocated in machine 1, and Question 2, question 1. Okay, so here start and both are getting the same order. That's why. Um, okay, I'll think about the sorry test case and tell you. Okay. Okay, fine. So any other doubts?
Yes.
That's it for today. We are completed greedy strategy. Okay, fine. So we can meet in the next class.
Okay, sir. Thank you.
Thank you.